Welcome, comrades. In today's discussion, today we want to discuss on the question of the grouped and ungrouped data to calculate the coefficient of variation and coefficient of skewness. You remember very well in the question we tackled on the measure of tendency and dispersion, we were able to cover mean, arithmetic mean. We were also able to cover the mode, median, standard deviation, and variance. So we were remaining with the last two parts, that question that carries 20 marks, to calculate the coefficient of variation and the coefficient of skewness. So I will start with the ungrouped data. We look into it, we calculate the coefficient of skewness and the coefficient of variation. Then after that, we'll look also for the grouped data. Good. So I will use the question so that it will guide us in our discussion today. So let's start with ungrouped data. So you can get, let me pick this one as our exercise 1 of the day, today being on 15th of February 2025. Good. So let's say you have the ungrouped data 6, 7, 10, 3, 12, 14, 8, and 12. So that is the ungrouped data. Then you have been asked to calculate 1A, calculate coefficient of variation, that is 1. Then calculate part B of that question 1 to calculate coefficient of skewness. Good. So with that question, I will start with how to calculate the coefficient of variation. As we all know, coefficient of variation, so you write CV, I mean coefficient of variation, you are supposed to be given by sigma. When I say sigma, that is a standard deviation. This means standard deviation. You divide by mean. Then you multiply by what? You multiply by 100%. Multiply by 100. That is the formula for calculating coefficient of variation. Good. So comrades, what you are supposed to do with this question, the first thing, arrange your data in ascending order at all the times. The moment you have been given ungrouped data, arrange it in ascending order. So first thing, I will arrange my data in ascending order. So it will be, now arrange, I will arrange in ascending order, or from the smallest to the largest. So that means my data will read 3. Then I will have 6, I will have 7, I will have 8, I will have 10, I will have 12, I will have 12 also, because there are 2. Then I will have 14. Good. I will arrange my data in ascending order that way. Good. Then step 2, you realize in our formula here, we are supposed to get what? We are supposed to get mean of the same data, also to get the standard deviation. So learners, what I'll do, let me start with the mean, which is very easy. So mean for the ungrouped data, which is very easy, we always say it is equals to a total summation of x over n. X in this case is the value of the items you have been given. So x here, like x1, 3 is our x1, this one is our x2, this is our x3. Good. This is our x4, x5 as you proceed. So mean, it will be x1 plus x2 plus x3 divided by n. That is what I mean, total summation of x. And the n in this case represent the total number of items you have been given. Like for this case, you have been given how many items? 1, 2, 3, 4, 5, 6, 7, 8. So our n in this case will be what? Our n in this case will be 8. Our n in this case will be 8. Good. So you'll go ahead and add So if I add that one, that is 3 plus 6 plus 7 plus 8 plus 10 plus 12 plus 12 plus 14. Then I divide by n, which is 8. Here I will have the total here becomes 72. I divide by 8. So my mean in this case will be what? 72 divided by 8, which I will have 9. So I will write very comfortably that my mean has got 9. Good. So that is first step, the second step in that question. So it means we have to calculate what? Now the standard deviation. We have to calculate the standard deviation. And remember very well, I had talked about this standard deviation, but we are going to repeat for the case of calculating the coefficient of variation. Now, to calculate the standard deviation, we'll have to come up with a small table here. So I'll call this one x. And this x now represents the values of items have been given here. So my x here, the first x will be 3. Then I will have 6. I will have 7. I will have 8. Then I will have what? 10. I will have 12. 12 because there are 2. Then 14. Good. So that is the first value. So I'm in the heading of heading to calculate what? Standard deviation. You want to calculate standard deviation. Good. So after that, in that table, I will find something called x minus mean. X minus mean. Already we have mean, so it's x minus mean. X minus mean. X minus mean. So already I have mean. For this case, it will be 3 minus 9. You know, so it will be 3 minus 9. I will have here what? Negative 6. 6 minus mean, which is 9. I will have a negative 3. 7 minus mean, I will have negative 2. Then 8 minus 9, I will have negative 1. 10 minus 9, I will have 1. 12 minus 9, I will have 3. And then I will have here 3. Then 14 minus 9, I will have 5. So you see, learners, we are heading somewhere. So after that, you do what? Now, in the next column, in that small table of calculating standard deviation, I will do something we called now x minus mean. Remember here it was x minus mean, but here it is now x minus mean squared. Meaning what? I'm going now to square the negative 6, negative 3, negative 2. You see? Now, so it will be what? Now, mean of this, if you square this, it will be here. Remember, if you square negative, like this case, we want to square negative 6. You square negative, it becomes a positive. Now, if you square negative 6, it will be 36. Here it will be 9. Here it will be 4. Here it will be 1. 1. Here it will be 9. 9. Then here I will have what? 25. Here I will have 25. Good. So, what next now? Let us get the summation of x minus mean squared. X minus mean squared. So we want to get the summation. When I give summation, it's just that one. So we are getting the summation of x minus mean squared. X minus mean squared, which we already have the figures of x minus mean squared, meaning we want just to get the totals of this. So the total of this 36 plus 9 plus 4 plus 1 plus 1 plus 9 plus 9 plus 25, I'll have 94. I'll have 94. Good. 94. Well done. So that is the case. Now, so we have a total summation of this, we have 94. Good. So that is good. So after that, we have to now to calculate what? We want to calculate the standard deviation. Standard deviation. And before calculating the standard deviation, we will have to calculate what we call variance. We'll have to calculate variance. And for this case, variance, we normally say variance is equals to total summation of, in bracket, x minus mean squared. You divide by, you see, variance, total summation, or divide by n. You divide by n. Good. You divide by n. Now, you divide by n. Good. Now n, in this case, I remember I told you n, our n is what? The total number of items we have been given. The total number of items we have been given. Good. So that is that. Now, so to get our variance here, it will be what? It will be now 94. 94. We divide by what? N, which is 8. N, which is 8. So I will have 94 divided by that. Our variance in that case will be 11.75. So this is our variance. This is our variance. Good. Now, what next now? You want to calculate, our aim is to get the standard deviation. Now, variance. If you have variance, comrades or students, fellow learners, it's very easy. We always say the standard deviation is equals to the square root of what? The square root of variance. The square root of variance. The square root of variance, which is very easy. So you can see the goodness of us starting to calculate the variance. So if you have the variance, it will be just the square root of that. Or you can say the standard deviation is equals to total summation, the square root of total summation of x minus mean squared divided by n. If you will skip to calculate the variance first, but you can start with this calculating the variance, then come to what? The standard deviation. So, but if you have this total summation and you have your n, you can get the standard deviation direct. So meaning, now I will come here, the standard deviation will be now, with this, it will be now, if I have already the variance, so the answer will be just the square root of 11.75, because we have said standard deviation is equals to square root of variance. So it will be 11 square root of that. So the standard deviation will be what? Standard deviation will be 3.43. So in any given time, variance will be always higher than a standard deviation. Good. So we go back to our question. Our question wanted us to calculate what? Our question wanted us to calculate the coefficient of variation. And we say coefficient of variation, we said is the standard deviation, the sigma, the standard deviation, or can put in brackets standard deviation, you divide by mean, multiplied by 100. Good. So if we have already the standard deviation, we have 3.43. You divide by 3.43. You divide by mean. Mean we got what? Mean we got 9. Mean we got 9. Yes, mean we had 9. Mean we had 9. So divide by 9, multiply by 100. So I will have what? I will have my standard, my variance there being, what? Now you can do that using your calculator. It will be what? 3.43. You divide by 9. I'll get multiplied by 100. I'll have 38.11%. 38.11%, or can be just 11. Good. So that is coefficient of variation. So you see, the first thing you have to do what? Calculate, arrange your data first in ascending order. After that, calculate mean. After you calculate mean, come and calculate the standard deviation. After you calculate the standard deviation, the way we have done it here, come and do what? Now just insert the values in our formula of coefficient of variation. You realize you have what? You have done a good job. Good. As we always say, we are here to simplify this mathematics and statistics, even the accounts. So those who normally say that statistics are hard, no, let us just change the mentality, and I assure you, if you keep following, all this is going to be easy and to make our learning comfortable. Good. Now we are just remaining with something skewness, that is coefficient of skewness in regards to this. Then we go to the ungrouped, we go to the grouped data. So let me go to the coefficient of skewness. Coefficient of skewness. Good. Coefficient of skewness. Coefficient of skewness. Good. Coefficient of skewness. So learners want to calculate the coefficient of skewness. Now, remember our question was, we are still on this exercise. We have done already the coefficient of variation, and our data was 6, 7, 10, 3, 12, 12, 14, 8, 12. So we have already done the coefficient of variation. We want to calculate the coefficient of skewness. Coefficient of skewness. Good. So the coefficient of skewness, the first thing we have to coefficient of skewness. What the formula of that? You know, we have different types of skewness in this regard, or the formula. First, you have to know what is the coefficient of skewness, and we always say coefficient of skewness is a measure that is used to determine the strength. Is used to determine the strength and direction of a skewness of a sample for distribution by using a descriptive statistics such as mean, median, and mode. Mean, median, and mode. So we are going to calculate the skewness here using either mean or we can use mode. Good. So in short, it's used to compare a sample of distribution to a normal one. A normal one. Good. So let me give you the formula. So here we are going just to use using the person second coefficient. I think that is the formula we use for today. We can also use the mode to calculate, also use the median, as we have said in our definition. So using the median, or you can say the person second coefficient, we normally say is 3 in bracket, mean minus mean, or you can write the name, or just use that as simple, mean minus median, minus median, minus median, you divide by what? Minus median, you divide by standard deviation. Divide by standard deviation. You divide by standard deviation. So the goodness of this, we have already calculated the standard deviation. So that you have to note that. Remember our standard deviation, we calculated our standard deviation already. Our standard deviation for this data was what? Standard of deviation of this data was 3.43. So that was the goodness of us to calculate that. I think all of us can see. Let me show you the standard deviation. We already have here the standard of deviation. We already have a 3.43. That is there. Then in that formula of a coefficient of skewness, also mean. And we have already calculated mean. We had mean what? You see how we calculated mean? We already have 9. We have 9. So you realize in this question of ours, we just have to calculate median. We have to calculate median. You have to calculate median. Good. We have to calculate median. Now, if we have already the mean, so we have our mean here as 9. So we are remaining with what? Median. Median, you can write median or you can write Q2. I always say that, Q2. So this is what we are missing, Q2. Now, the first step in calculating median in this case, arrange your data in ascending order, comrades or students. Arrange your data in ascending order. That is the first thing when you are calculating this mathematics, or when you are dealing with the ungrouped data. So when we arrange our data in ascending order, you will realize we will have here in ascending order, you will have 3, then you will have 6, you will have 7, you will have 8, 10, you will have 12, then you will have 14. So that is the first step of arranging the data in ascending order. Now, there are two ways you can approach this question to calculate median. One is very simple. Median, for this case, you'll come here. The first value or the first item, this 3, will go with the 14. That is the first method. First method of approaching. First method. I'm demonstrating the first method of calculating median. Q2. Calculating median. The first value cancel with the last value. The second value cancel with the second last value. So it will be cancel with that. Then 7 will cancel with the third from the last. Then you realize if I cancel 8 by 10, if I cancel 8 by 10, I will remain with nothing. So I have two values in the middle. So what I'll do, I will add two values, which is 8 plus 10 divided by 2 to get my median, So 8 plus 10 is what? 18. 18 divided by 2, I will have 9. 18 divided by 2, I will have 9. So my median or Q2 in this case is 9. It's 9. You see? Good. Method 2. Second method, which I want you to pay attention. Second method, we always say Q2 of calculating median, we always say 1 over 2 into bracket, n. N, when I say n, I say the number of items you have been given, plus 1 nth item. Good. So that is, you want to see how you want to calculate median with that formula. Good. Now, so you have to calculate first. Now remember your data you have arranged in ascending order. So we are referring to this data here. You are referring to that data. So I will calculate first my nth item. And nth item here is not the answer. I will go to the data that I have arranged in ascending order. So it will be here 1 over 2 in bracket. N is what? The total value items are how many? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. So it will be 8 plus 1. 8 plus 1. Nth item. So I will have 9 divided by 2. It will be 4.5. Nth item. Good. I think this is a good question. Good. I think this one is good. Because if I could have gotten just 4, without that point, I could come just direct to my data I've arranged in ascending order and look for the fourth, the item that is on the fourth. So, like this could be what? 1, 2, 3, 4. I could have picked 8 as my median. But it has got now a point, which is a nice one. I want to show you that. I think this was a nice question, actually. So, when you have 4.5 as your item, now you cannot, it's not easy just to go and pick 4.5 on this. So you have to do some calculation here, approach. Now, 4.5 in this case will be what? You have first to split this 4.5. If you split 4.5, it will be what? 4 plus 0.5. All of this is nth item. Meaning, if I add 4 plus 0.5, I'll be just back to where? To 4.5. I'll be just back to 4.5. Good. Now you have splitted. That was the first step on that approach. What we do? We go and look for the fourth item on our data. Remember our data we have here is what? Let me put it here. Now that one we have interfered with it. It is what? 3, 6, 7, 8, 10, 12, 14. This is our data. So we have to identify the fourth item first. The fourth item in this case will be what? 1, 2, 3, 4. The fourth item is here, 8. So I will write here 8 plus, remember 0.5 plus 0.5 in bracket now. Now I was on fourth. It will be, I will go now one step ahead, which is now 10. The 10th value after that 8 is 10. Now I'll go remember we were picking on the fourth item. So I will pick now the fifth item minus the fourth item. So the fifth item in this case is 10. Is 10 minus 8. Good, minus 8. Now it will be very simple. It will be now 8 plus 0.5 in bracket 2. So it's the same as half multiplied by 1. Half multiplied by 1 is 1. So it will be 8 plus 1, which is our Q2 will be what? 9. Is it not the same as what we did here? It's the same. So there are those two approaches you can use to calculate median. Now let's go back to our question. Our question wanted us to calculate the coefficient of skewness. Coefficient of skewness, we have said it is what? 3 into mean minus median over standard deviation. So I'll just go direct. So coefficient of skewness will be what? 3 in bracket. Our mean was what? 9 minus our median 9. Our median 9. Good. Then you divide by standard deviation. Standard deviation we got 3.43. Good. So here the answer will be what? 9 minus 9, 0. 0 multiplied by 3, 0. So at the end of the day, our coefficient of skewness is what? 0. So if you get 0, you are not wrong. We are not wrong. Because in skewness, we normally say, if skewness is 0, there is no skewness. So not this one. If skewness is 0, there is no skewness. And if skewness is positive, if in case we could have gotten here 1, because we will do another question, we will get here positive 1. If skewness is positive, it means the skewness is also positive. Remember we said the skewness is used to compare a sample of distribution of normal. Good. And if skewness is negative, if in case you could have gotten the answer here as negative, it means the skewness also is what? Negative. So this is just a measure of our statistical data. Statistical data. Good. Think that is how to calculate the standard deviation, how to calculate the coefficient of variation and coefficient of skewness in regards to do what? To ungrouped data. Good. So as I've said, this calculation of mathematics is very easy, especially for what we are doing. That's why we have this channel to help us so that we can learn more and maybe to aim as we continue helping one another to make sure that we simplify this mathematics and statistics, and in addition to also accounts. So there is beauty behind the mathematics, behind the accounting. So this is the beauty of this. I really love this. Now, if you have any question, maybe after you have gone through this and maybe you want more clarification, you can leave a comment in the session, in that comment section, so that I can handle them when we meet in our discussion, our normal discussion in the course of the week. So for today, that is ungrouped data. I'm going to do the same coefficient of variation and skewness for grouped data. So for today, may God bless you wherever you are, and continue following up, continue subscribing so that we can learn together. Bye-bye.